So hello guys. So here we will be continuing our lectures on torsional loading. So here in the torsional loading case, first of all we have to understand few things. The difference between the bending moment and twisting moment, right? Because of the twisting moment only, the shear stress will be generated, right? So note down the few points regarding this, the difference between the bending moment and twisting moment, right? So put a note here. Note number one. When the plane of couple, when the plane of couple is same as plane of cross section, then we say that movement, that couple, to be called as twisting couple. As you can see here, this and this will create some kind of movement like this. This movement and this cross sectional plane both are same. One more specialty there is, some special thing is about the twisting couple, is that it is acting about the longitudinal axis. What is the longitudinal axis? Which is passing through the axis of the shaft, or perpendicular to the cross section, right? Second point, when the plane of couple is perpendicular to the plane of cross section, then we say that couple or movement to be called as bending movement, or bending couple. Getting my point? Now regarding the sign conventions, you please note down this few sign conventions. That is a very important sign convention. Whenever any member is there, if I take any axis xx, if the twisting is happening like this, then we write it as plus t. Whenever the twisting is happening like this, then it will be minus t. Then how to convert from the twisting diagram to line diagram? This particular conversion, how it will happen? Simply rotate your right hand fingers. Whenever the thumb, suppose you are rotating in this sense, your finger you rotate it in this sense, where the thumb is going? Thumb is going away from that, like this, double arrow. If you rotate your finger like this, it will be something like this, right? So for this figure, if I just write here point number A, this is as point B, this is at point C. If I take any section in between B and C, Txx in B and C, then what I will be writing? Plus T2. If I take in AB member, in between AB section, if I take any section, what will be the twisting load? Plus T2 minus T1. Why minus T1? Because it is according to our sign conventions. According to our sign convention, if we are moving like this, whenever we find like this, we put negative. Right? So these are the regarding the sign conventions, which are very important. Note on the torsional formula. Torsional formulas, very important. T by J, tau by R, G theta by L. If I just equate these two, I will be getting what? Tau by J, that is equal to R theta by L. And according to Hooke's law for this here, tau is what? Directly proportional to Y. Tau will be what? G times of Y. So this will be Y. So what about this term? This term will be represented by what? Gamma, that is shear angle. Or we also call this to be a shear strain. We also call this to be a shear strain, my friend. Right? Shear stress will be directly proportional to radius. Everyone know that. The shear stress will be directly proportional to radius. Everyone know that from this twisting formula. Very much clear. Right? There's a no warping. If there's a warping will happen, the cross sectional will changes. Then which radius you will take? To avoid that confusion, we will take only The one assumption that there is no warping. And how to decide the direction based on this tau xx. Suppose we have the plane of the cross section is what x, and in which direction it is acting. Suppose it is acting in this z direction. So what will be writing tau xz. X face z directions, right? S is nothing but the circumferential directions. If you want to write here, then tau x y. If I just take this axis to be y, this axis to be z, right? So these are the few things which are very important regarding the torsional formulas. One important relation is there between the shear strain and the angle of twist. Theta or phi, we are calling this to be angle of twist. Angle of twist. Generally, angle of twist will be proportional to what? Length. That means it is depending on the what? Length. And whereas the shear strain depending on what? The shear strain depends on radius. Depends on radius. It does not depend on the what? Length. Let me just show some of the important figure regarding that. So here I am just twisting by the amount this. So this will be line joining of this one. Something like this. This will be gamma. So here what I'm writing by different, you understand, I'm just taking one more section view here. I'm just taking one more section view. You can see very clearly the angle of twist depending on the what? Length. Just check it out from here to here. You compare yourself. Here, whatever the angle of twist is there, let me call phi. You will observe that phi dash is what? Less than phi. Check it out. Here at the free end, we have the lot many amount of angle of twist, but here it is not. And here it is zero. Here the angle of twist will be zero because it is fixed, Angle of twist will be zero at the fixed end. But the shear strength would not depend on the what length. Either you consider the section here or you consider section here. The shear strength will be same for A and for B section. It will remain same. Shear strength will depend on the radius, right? If you just consider somewhere here, that case it will be different. If you just consider somewhat, the radius would be here, and if you just twist it, you will be getting something like this. This will be the gamma dash. Gamma dash will be less than gamma because it depends on the radius. More radius, more gamma. Why? There is a formula R phi by L. We can also write R into phi by L. So gamma is what? Directly proportional to radius. Because phi is what? Proportional to L. So they will cancel out. So gamma will be what? Proportional to radius. These are the important point, but most of the time it is being neglected, right? So note down, this is a very important. Now, few more things we will discuss about this distribution of this air stress. Now, generally, what we are observing, if I just take these circular cross sections, that is a solid circular cross section. If I take these solid circular cross sections like this, if I take the solid circular cross sections, my different. If I take solid circular cross section, then what you are observing, gamma, that is a strain, is also proportional to radius. Strain is also proportional to radius, and the shear stress is also proportional to radius. Both will be varying linearly. Both will be varying linearly, my dear friend. This is the gamma max. This is the tau max. Here also tau max. Right? Gamma is directly proportional to radius, and so shear stress. But what happened with this hollow circular tube? How the variations would be there? As you can see, the variation would be something like this. Let me make it more clear. So if we just take the view, what will be the view, my different? That's a very important. The shear strain, it will be maximum, then minimum. There will not be any value because it is a hollow one. Then it is going to be something like this. Here it is gamma minimum. Here it is gamma maximum. Again gamma minimum, gamma maximum. Once again, we're gonna have particular values we will be writing. Tau maximum, tau minimum, tau minimum, tau maximum. Right. So this is nothing but the shear stress variation. This is the shear strain variations. What is this shear strain variation? This is a shear stress variation. Very, very important point, my dear friend. Right. Apart from it, the polar moment of inertia, it's a very, very important thing. Polar moment of inertia. For solid circular cross section, J can be written as pi d power 4 divided by 32. Right? What about the polar moment of inertia? Polar moment of inertia for hollow circular cross section. For hollow circular cross section, note on the formula. For hollow circular cross sections, you can note down the formulas. Something like this. Inner radius is R1. Outer radius we are considering as R2. Thickness I am considering as R2 minus R1. Mean R1 minus R1, R2 minus R1. Mean radius I am considering as R1 plus R2 by 2. So pi R2 power 4 minus R1 to the power 4 divided by what? 2. We can also write pi d power 4 minus d1 power 4, 32. We can also write in terms of mean radius and thickness, pi rt divided by 2, 4r square plus t square. Remember, these are the exact formulas. R is the mean radius. R is the what? Mean radius. T is nothing but the thickness. We can also write pi dt by 4 divided by d square plus t square in terms of diameter, mean diameter. What is that? Mean diameter. d1 plus d2 by 2. But for a very, very thin section, but for a very, very thin section, but for a very, very thin section, but for very thin section, but for very thin section, my dear friend, we can neglect t square. T will be very, very small. T square will also be very, very small. And we can neglect that. Then approximate formula will be, J approximate formula will be pi d cube t divided by 4. That is the approximate formula. Remember, approximate formula when t square will be taken as 0. Right? So this slide is very important. Most of the time it is being neglected, and that's why in examinations multiple times they have asked the question based on the hollow circular tube. Either they will be asking you the formula, either they will be asking you the calculation for the shear stress, either they will be asking for the calculation of the twisting moment. You will do the lot of mistakes. So better that you just focus on this slide very well. Right? Now let's focus on the numerical part. That is very, very important for us. Now, what you are understanding from this numerical, read the each and every line. As we are taking into this particular series a very, very good numericals based like good numerical from all the topics. Horizontal rigid horizontal rod of the length 2L is basically fixed to the circular cylinder of the radius R as shown in the figure. The vertical force of the magnitude P is applied at the ends. What is the they are asking this, what they are asking, vertical deflection at the point A. Vertical deflection they are asking. After some point of time it will be deflected like this. So this is what the deflection they are asking, vertical deflection they are asking at a point. That's quite easy, quite easy. Whatever the angle of twist will happen, with what angle of twist cylinder will happen, with the same angle the rod will be deflected. And we know that tan phi we can write gamma by L by 2. Getting my point? Sorry, it is not L, it is what? Half of this angle will be what? Already they have given L. So gamma can be written as tan phi is what? Almost equal to phi. If phi is very, very small, tan phi will be what? Almost equal to phi. You can put into the calculator, you can get the answer. All together, we need to find what is the phi. Phi, what is the formula? T by J, G theta by L, G phi by L. So from here, what we can write? Phi, T L by J, Gj. So remember, theta and phi both are same. Notation wise, both are same. Right? So T into L divided by Gj. But what is the twisting? Twisting moment. P and P will create the twisting moment. Then twisting moment or T we can write P into what? 2L. Right? Into L divided by what? G into J. Put into that formula, you will be getting what? 2PL square divided by what? Gj into L. So what you are getting? 2PL cube divided by Gj. And you have to put the values of J also. J is what? Pi d power 4 divided by 32. Or we can also write pi r power 4 divided by what? D, that is 2r, that is 16 divided by 2. So when you put the values, you will be getting what? Answer is D. So only the twist in this question is to recognize the relationship between angle of twist and what? This one. Right? Remember, this is not a shear strain, right? You must be bothering about that. So let me change the notations. Vertical deflections, vertical deflections, vertical deflections, vertical deflections, right? Vertical deflections at a point, at a point. Now, we'll try to solve this numerical also. Now, consider a stepped shaft which is being subjected to a twisting moment, something like this. At the B point, Shear modulus they have given, they are asking what is the angle of twist. Angle of twist at C, we can write angle of twist C with respect to A. Whenever they will be asking you angle of twist, you have to calculate angle of twist with respect to fixed end. Phi C with respect to B plus B with respect to what? A. We can write like this. Phi C with respect to B is what? What is the torsional of C? That is the angle of twist of C with respect to B. TCB LBC divided by GBC JBC. Formula is what? Formula we know that, TL divided by GJ. Same formula we are using over here. Plus TAB, LAB, GAB, JAB. So what is the phi C, my dear friend? Phi C. First of all, we have to calculate twisting moment at BC. Any twisting moment is there? Nothing. See, this twisting moment, if you just convert into the line diagram, it will be something like this. So this is going to be something like this. This will be the reaction torque. This reaction torque and this torque will be equal. This reaction torque, this torque will be equal. So TBC will be what? 0. TBC will be 0. Either you see from the right side or left side. 0. Getting my point? Now, what is the TAB? TAB, if you just take any section, what you are observing? Minus. You are getting what? Minus. You are getting what? Minus, because it is coming towards section. And if you just rotate your fingers, it is going like this. So what you are observing in this one, it is something like negative minus T, that is 10 Newton meter. Put this value, TBC 0. So phi will be what? TAB is what? Minus 10 into 1000 into L is what? 500 divided by Z is what? 77 into 1000. Pi d power 4 divided by 32. So when you calculate, you will be getting the answer in the radians. So you will be getting minus 4.13 into 10 power minus 3 radian. They are asking in degree. So how to convert radian from degree? Multiply 180 by pi. 180 by pi. So you will be getting what? 0.2369 degree. That will be the answer. Right? So in this manner, we have to solve the numericals. Right? Now, when you focus this one, this is nothing but, this problem is known as statically indeterminate problem. Statically indeterminate. Statically indeterminate problems. Why we are writing statically indeterminate problems? See, both the ends are fixed. So there will be some kind of line diagram. Draw the line diagram. This is a point A. This is a point B. And this is a point C. So if I convert this diagram to the line diagram, what we are observing, my different, if you rotate your finger, you will be observing that it is like this, T naught. There will be some reaction torque, RA. Let me write TA. Let me write TC. TA and TC we can write. That is a better one. So summation of torque in the horizontal direction should be 0. So what we are writing from here, TA plus TC is equal to what? T naught. So we cannot find with the help of only one equation, we cannot find the values of T and TC. We need one more equations. That's why we are writing statically indeterminate. With the help of the static equilibrium equations, we cannot be able to determine the values. We need additional equation. Additional equation is what? Total angle of twist C with respect to A has to be 0. That means phi C with respect to B plus B with respect to A has to be 0. Phi C with respect to B is what? What is the torsion in BC member? What is the torsion in BC member, my different? Plus TC. What is the torsion in AB member? You have to check it out from either section. Either left side or right side. Don't look at both the sides. So you can write minus TA. Or if you just want to calculate from the right side of this X section in the AB member, then what you can write? What you can write, my different? minus T naught plus TC. Getting my point, right? And from here, from this equation also, what you are observing, T minus plus T is what? T naught minus TC. Then minus T is what? Minus TA will be TC minus T naught. No problem. Same thing you are getting. Now put into that equations and let me know the answer. What is the phi C with respect to B? TL divided by GJ of BC. What is the TBC? TBC is what? TC. Length of the BC is what? 3L by 4. G and J both are same for both the members. Diameter is same. This diameter and this diameter both are same, you know. Yes. J is also same. I mean, J is also same and G is also same. Material is same. Material is not different. Now, what is the TAB? TAB is what? What are the torque which are acting in AB section? TC minus T naught. The length is what? L by 4 divided by GJ. That will be 0. So 3TC divided by 4 plus TC divided by 4 minus T naught divided by 4, that is equal to 0. So we are observing TC is equal to what? T naught divided by 4. Getting my point? TC, what we are observing? T naught divided by 4. T naught divided by 4. They are asking what is the maximum shear stress in the shaft. So we have to check it for AB, we have to check it for BC, and we have to club together and tell the answers. Now here what we can write? TC. So TA will be what? TA we can write T naught minus T naught by 4. So TA will be what? 3 T naught by 4. Now once we get the each and every data, it's a fraction of putting the value and getting the answers, right? So if I just remove this diagram for our calculation purpose, we got each and every answers. Now we have to just substitute and get the answers. What is the torque in AB member? See, T by J, tau by R. Tau will be what? TR by J. Can we write like this? TAB, R of AB, J of AB. My dear friend, D of AB is what? Minus of TA. Minus of TA is what? If I just calculate the magnitude, then I will be writing 3T naught by 4. RAB is what? Radius is R. J is what? Pi d power 4 divided by 32. Pi r power 4 divided by what? 2. So what I will be writing, my dear friend? I will be writing over here something like this. 3T naught divided by 2 pi r cube. So from here, what we can write? Tau AB, 3T naught divided by 2 pi r is what? dq divided by 8. 12T naught divided by what? Pi dq. This is the magnitude of the maximum shear stress in AB member, right? Getting my point. What is the tau in BC member? TC. What is the TC? T naught by 4. Remaining things will be same. Radius will be R, so we will be writing d by 2. J is what? Pi d power 4 by 32. So if you just calculate once again what you are observing it as 4T naught divided by pi dq. So which is a larger one? 12T naught or 4T naught? 12T naught. So this will be the answer. So maximum shear stress will be what? AB. If they would have been asking the question, what is the maximum shear stress in the BC member, the answer would be 4T naught. Getting my point? 4T naught divided by pi dq. That means the option. But right now for this question, B will be correct. Right? So in this fashion, my dear friend, you have to solve the numerical of twisting. That is a torsional loading case. Getting my point? Thank you all.